So this next lesson is going to be all calculator questions. We will not have a quiz in class on Tuesday. Your quiz will be Thursday, and it will be a no calculator quiz involving the rules of logs, the definition of logarithms, and expanding and condensing and solving, all with no calculator. So first of all, I'd like you to think back to Algebra 1. In Algebra 1, you distributed, like 2 times x, and then 2 times 3 is 2x plus 6. And then you learned to factor. But distributing and factoring didn't really do anything. They were just practice, so eventually you could use distributing to solve an equation that looked like this. 2 times x minus 3 equals 12 becomes 2x minus 6 equals 12 becomes 2x equals 18 becomes 9. Or, so you could solve something like this, which required you to factor first. X minus 4 times x plus 2. So the solution was 4 and negative 2. So what I want you to think about is distributing and factoring weren't things by themselves. They were just part of the process of solving the equation. The same is true with logarithms. Expanding and condensing logarithms aren't the point of the problem. The expanding and condensing is what we do, so eventually we can solve things. Like this problem right here, I could solve by condensing it to log base 10 of 5x equals 2, then converting it to an exponent. 10 squared is equal to 5x. That's 100 equals 5x. And then x equals 20. Or I could solve a similar problem by taking the log of 10x and expanding it to the log of 10 plus the log of x. The log of 10 becomes 1. I subtract 1 from both sides. And the answer is 10 squared equals x, or 100. So expanding and condensing are things that we do so eventually we can solve logarithms. The rules for expanding and condensing have to do with the exponent rules. So I think of this first rule right here as when you multiply powers, you add the exponents. And so I think of this as the multiplication becomes addition rule. Multiplication becomes addition when you're dealing with exponents. Now, if we look right here, we take x to the fifth divided by x squared, we get x cubed. I think of that rule as the division becomes subtraction rule. And this last rule, I take a power of x, I'm looking right here, I take the power of x, and I end up timesing these two numbers. So I think of these as the powers becomes multiplication rules. And when we're looking at logarithms, because logarithms and exponents are inverse functions, all of these rules get switched around to their inverse. The same rules in log form. This is the addition becomes multiplication rule. This is the subtraction becomes division rule. And this is the powers becomes multiplication rule. And it is written kind of backwards, but it's generally applied in the order you see it right here, although not always. And then a good FYI, logs and exponents are inverses. So if it says the function is 3 to the x, you should know that the inverse function is log base 3 of x. Just like squaring and square rooting are inverses, and timesing by 2 and dividing by 2 are inverses. For log problems, the log and its exponent are inverses. Now you might want to pause the video for a second and take time to write down each of these log rules. And every time you see one of these log rules, it's helpful to say which one it is so you can get them straightened out. So when you're going through and doing a problem, say to yourself, oh, this is the addition becomes multiplication rule, or this is the subtraction becomes division rule, or this is the multiplication becomes a power rule. And the multiplication becomes a power rule can be kind of tricky. It might even be like you think of the I squared, poof, became a -1. You could think of it as if there's this m in front, poof, it comes up to here and becomes an exponent. These three examples are practice condensing. So when you look at the first problem, you see the addition sign and you think to yourself, oh, that's the addition becomes multiplication rule, so this problem condenses to log base 5 of 8x. So again, this is the addition becomes multiplication rule. In the next problem, you should notice right here, there's a power. So this is the powers become multiplication rule, and I take the x and I move it out here in front, so this condenses to x times log base 2 of 4, which then you should be able to evaluate log base 2 of 4 in your head, 2 to what power is 4, and condense it completely down to 2x. In the next problem, you should be looking at it and thinking to yourself right here, so this is subtraction. Subtraction becomes division. But then you also look at the 3 right here and think, oh, well, the 3 has to come up because that is the multiplication becomes powers rule. So you've got this 3 here is going to come up and be a power, but the subtraction is going to condense to division. And so this problem is going to be the log of 2 over 125. So condensing is taking something that's spread out and making it smaller. Expanding is spreading things out and making them bigger, so these examples are all of expanding. What you should look at right here is this is multiplication. And the rule about multiplication is that multiplication becomes addition. So I'm going to write this as the log of 2 plus the log of m, and then check out this m is to the 4th power, and the 4 comes in front, but the 4 is only going to come right here in front of the m, because only the m is to the power 4. On the next example, you look right here, and this is division, so you say to yourself in your head, division becomes subtraction. So you turn it into a subtracting problem, log lom, not lom, log of m minus log of x. But then if you look at this 3 right here, this 3 only goes with the m, so the 3 that comes out front comes in front of only the m part of the log, not the x part of the log. Now in the next example, the 3 applies to the 4 and it applies to the m. So when you look at the division sign and think to yourself division becomes subtraction, you're going to have log of 4 minus log of m, but the 3 right here is going to go in front of both of them because it applies to both of them. And again, condensing and expanding are just practice, so eventually you can solve logarithms. Most logarithm problems can be solved by condensing and converting. So in this problem, it would look right here, that's addition. And I would think to myself, well, addition becomes multiplication, so I'm going to condense this to log of 4x equals 2. And then I'm going to remember that because this is a common log, it has an invisible base of 10. So I condensed. Now I'm going to convert. This is 10 squared equals 4x. And then you're just going to use rules of algebra from there. Condense, convert, solve. So 100 is equal to 4x. And 25 is equal to x. Now, other log problems are first condense, then exponentiate, and then solve. So this problem right here, you would look at addition. Addition becomes multiplication. So this becomes log of x minus 3 times x plus 3 equals the log of 25. And then you would do what's called exponentiating. And since these are both logs with a base of 10, you can exponentiate them by taking them both to the 10th power. And then what happens is the exponentiation and the logs cancel, and you get x squared minus 9 equals 25. Now, that step right there just sort of, exponentiating, it just sounds terrible. So if you don't want to think about exponentiating, think about it as like, I know this is really silly, these are the matchy-matchy problems. It's like just take away the whole exponentiating thing. You see how the logs match? If the logs match, and this part over here must match, so therefore they must be the same. And so if you don't want to think about it as exponentiating, you can just think about, oh, they match. Then you can solve it that way. This would be x squared is equal to 34, so x is equal to plus or minus the square root of 34. All those, since you can't take the log of a negative, it's not actually going to be the minus part. It's just going to be the square root of 34. And you need to recognize when it's an exponentiate problem and when it's a convert problem, and they're pretty easy. I would do another example, but we're out of time to keep the video under 12 minutes.